For number one, this is one of those infinitely nested radicals. So to solve it, what we're going to do is we're going to start by saying we want to know what the value of this is. And so it must equal something, and we don't know what it equals, which is a prime opportunity to use a variable. And so we set this equal to x. And then it's now a equation involving a radical. And so a logical thing to do is to square both sides. And when we square both sides, we get 5 minus, and then we still have an infinite radical inside our square roots there. Just one of those came outside. And the theory behind these type of problems is that means that this infinite radical is the same as this infinite radical. It's the same idea as saying if you were to count from 1 to infinity and count from 2 to infinity, the number of numbers you would count is the same, even though you start at a different point. And that's a little bit unintuitive. For the purposes of solving problems like this, we can make the assumption that they are the same. And so we can replace, remember at the beginning of the problem, we said that this equals x. And so we can replace that with x. And so we get a problem that looks like that. And now we can solve that using quadratic equation. X squared plus x minus 5 equals 0. So x equals a negative b plus or minus b squared. The square root of b squared minus 4 times 1 times negative 5 all over 2 times 1. But because our square root here is going to be either positive or negative. If it was negative, our value would be negative. But this, as a square root, has to be positive. And so we are only going to have the positive part. Simplifying this inside there, you get 21. And so you get square root of 21 over 2. So negative 1 plus the square root of 21 over 2 is equivalent to this infinitely nested radical.